All right, so this lecture is about Module 2B slide. And this particular slide is actually a summary of your Chapter 3, mostly. A little bit on Chapter 4, as I just mentioned to the student in the room here. And so let's kind of take a look at, and I will present some of my personal perspective on this normalization theory. So Module 2B is about normalization theory, and it's about Chapter 3 and Chapter 4. And there is a data set you will be seeing in Module 3, learning module. And we're going to be using Chapter 4 data for another important learning in the future, but not immediately. So that's why I didn't put this in Module 2. But there are some usage you know. We're not going to be talking about that today, but we'll come back and use that later in our class there. And so this is a scenario, right? And this scenario is important. And what we are assuming here is that some of us are new to database. So every time when you are going through a learning module, and personally, I think it's very important every time you learn something as a graduate student, you need to know why are you learning that stuff, right? So you're not just going there and say, okay, the reason I'm learning this stuff is to get a good grade. Now, grade is not important, actually, especially for graduate student. Now, you need to outsmart, or you need to be better than your either career competitor, or you have to be a good contributor to the organization you're working for. So you got to know what you are learning and why are you learning that. Once you know that, you know how to apply this to your job, to your real life, and to contribute to as a professional. So that is an important thing. So at this particular point in time, you should know something about the environment. So you play around the tutorial, you learn about the environment, and you also learn some basic about the SQL select statement, right? And hopefully you know that the reason we learn select statement is to build report. So to retrieve data from database. And it's called the data manipulation language. We manipulate the data you retrieve and generate a report, right? So that's what we are actually doing here. And Chapter 3 and Chapter 4 now start getting into the topic of database management, starting by looking at what are the fundamental database problem that we'll have, right? So the database problem we have from the very beginning is that we want to make sure the data you collect here is organized. And once the data set is organized, then you can present or do any calculation or process this data set easier. So organizing data becomes an ultimate goal in the I was going to be using the word past, but it is not really the past. It's just it's the nature of a thing of human being. We like to keep things organized, right? So even though that most of the time we fail to do that, I've been teaching information technology for more than 20 years, and one thing I my major in PhD program is management, but I still feel like I cannot manage my office even in a very good order, regardless of the computer file or data you have in your computer. So that is the goal. But when you are using this in a more formal setting, commercial setting, or some setting has legal implication. Commercial setting have legal implication because you need to pay tax for your business operation. So once you have to pay tax, bookkeeping, doing this accounting job become an important part of the data management. So you got to keep things organized. So that is one. How do you organize data? And over time, the people organize data in mostly in paper or on papers or in the environment like Excel spreadsheet. So our textbooks just assume typically you have a spreadsheet. Everybody just you start a company and you start using a spreadsheet, try to collect, okay, today how many pen I sell, how many book I sell, how many hours of consulting service I do, and how much bill I have paid. So you keep track of that record, and that is fine initially without any structure. You just roughly and put them into a spreadsheet. Every data you want to keep, you use a column to do that. That is fine initially, but after you work on that for a while, you encounter problem. And these red part are the problem that you might encounter in your Excel spreadsheet data set. Right? It could be incorrect. Could be some data missing. It's a human tendency to type something wrong from your keyboard, or somebody telling you something just like you have a typo when you write something. So all these are possible scenarios. So anything can happen in a human society 100 years ago. It can happen in the digital era as well. So if you keep a data set using the spreadsheet type of technology, but of course hyper jump to 10 years from today, or maybe 20 years from today, we will have more sophisticated artificial intelligence to help you make sure that whenever you do something, the data is either automatically collect, or the artificial intelligence can help to make sure they can detect the data error before it happens in the database. But before we reach there, there's still a need to handle these issues. So that's what normalization theory is all about. But initially, normalization theory is not designed to handle those problems from the spreadsheet. It was created to design a new database, right? So that is where the little history you can read about. So in the first couple of classes, we talk slightly about the history. Here is more a formal introduction to where our major database called the relational database was introduced and created. It was introduced in 1970, actually in the middle of 1977, if I remember correctly. So by Dr. Cott in IBM, he was IBM engineer. In earlier IBM, they have created a lot of guru, if you want. A lot of these people set technology standard for us. We are still using until today. So this is one of those. So Dr. Cott created this relational algebra, and this is the IBM's effort to design the IBM DB2 database. Right. So that's where the database is all coming from. So very quickly become a standard model for database, and of course, following IBM, the biggest relational database player is Oracle, and they turn out to be the biggest database vendor. Actually, surpass IBM they're still the biggest database if you do not count the cloud database today. So that is the history of relational database. And their terminology when we are learning normalization theory, and this terminology is one of our main learning objective. So as a MIS student, you should be able to understand these terminology not from only a practitioner's perspective, right? Because a lot of practitioners, they use this terminology, but a lot of them use that incorrectly. To make sure that you get all these ideas, and now in the lecture today, I will try to summarize or emphasize on some of the things here. I do have a few questions in the practice quizzes, and as well as in your midterm exam, to make sure that you're not tricky questions. You're not tricked by those questions. Right? So these include primary key, candidate key, surrogate key, composite key, foreign key. It will be a good idea to relate key to column, right? Column. And in database design, when we say column, it's something what we call physical database design. Now, when we say key, a lot of time we call this logical. And but many of you have learned the entity relationship diagram, something we call conceptual database design. And because conceptual database design and logical database design and physical database design, for practitioner, they sort of like mix them up together already. So a lot of time these terminology will be used interchangeably, column, key, and the other important things called attribute. So a lot of time we say, oh, this is the attribute for student table. Theoretically speaking, it's, well, actually not theoretical, it's correctly speaking, it should be the column in student table, not attribute in student table. The correct way of saying that should be attribute in student entity. But when you are seeing a table or a spreadsheet, that's a column in the table, right? So that's kind of a small differences, but people have a lot of major mistakes, believe it or not, are coming out of this type of misunderstanding, because people will misunderstood the conceptual data that people try to design. Conceptual, you can see this is ideal. This is something we want to be. But a lot of time when we implement the database, there are a lot of changes in implementation. Create additional keys, such as something what we call the surrogate key, or using an alternative method to index or try to describe the object, or adding additional column, additional to the attribute itself. So those are the problems that we might encounter in database management. So the next fundamental knowledge to understand before you really can understand the background or the theory behind to support the normalization theory is functional dependency. And to be honest with you, when I was taking the database class, my professor is a very good professor. He's actually very famous in the AIS world. His name is called Arun Rai. He's now a professor at Georgia State University, and he is a chief editor in one of our top journal. So, but anyway, because he's coming very strictly from the academic background, when I took his class, he emphasized a lot on this theoretical discussion about the normalization theory. And that is a very challenging discussion, even for the classes at the PhD level student, right? So if we put this into the master level or undergraduate level, it will create a lot of this logical confusion, right? It's kind of like you study philosophy. People, and I don't know about the United States, but when I was younger, then taking the college entrance exam in our home country, one of the joke is that if you study philosophy, that you try to look at that. 1/3 of them commit suicide at a certain point in their lifetime. 1/3 of them never get married. The other 1/3 then will be just becoming the labor workforce, will not get a job and will be just doing whatever they are doing there. So it was like a joke about people doing philosophy. But when you are studying normalization theory, you do need to have a very good logic deduction mind in there, very clear mind. So even though I've been teaching normalization theory for many time, and it's still, if I'm in the bad condition, I will still make wrong judgment or look at the normalization incorrectly, right? Just let you know. All right, so let's start with the normalization theory, and we blend in how are we going to normalize a data set to the theory itself. So we're going back and forth, putting practice and theory kind of together. The first thing about normalization theory is something what we call normal form. Normal forms are normal means that we are making the data better, right? Normalize the data, so the data become normal, not random, not erratic, not kind of something that not organized. So the first thing to do in organized data is to put them into a table. Now this job of putting them into table is called relation. So this is actually the first word in relational database. Now the relation as a table is different from the table as we most people know it, right? And how do I say that? Actually, the answer is on the slide already. basically in relational database, a table is a table that does not waste any memory space on your hard drive or in your computer system. Okay, by the way, there are two main purposes, and those two main purposes of doing normalization theory or using normalization theory to normalize data. One is something we talked about already at the beginning. We said that the problem of data quality. We want to make sure data quality is controlled. So ensure data quality, or we have another terminology we call ensure data integrity. Right? Data quality, data integrity. So that we consider that the same thing, right? Data, in order to maintain the data quality, we do normalization. The second most important purpose, which is less discussed in today's environment now, is called efficiency. Right? Efficiency in terms of what? Efficiency in terms of you do not waste. You do not waste. Do not waste what? Do not waste valuable memory. Because in the past, in the old time when IBM was putting out this mainframe computer or the IBM DB2 database, hard drive or random access memory or RAM, both of them are extremely expensive, right? So I remember my first hard drive was 10 megabyte, small, and that 10 megabyte hard drive cost me about $200 back in 1984. Yeah, 1984. Like, what time was that? No, actually, yeah, that's about right time. 1984, 83. I got my first computer, IBM 8088, personal computer, and I spent all my parents' savings, not my money. I bought a hard drive, 10 megabyte, to build a database, keep track of our classmates' information. I built a database just to play around with my classmate. But that tells you how expensive it was. So the other purpose, second purpose of normalization is to reduce the waste, to make your database memory more efficient, right? Reduce the waste. So these two purposes, data quality, reduce waste, or some people call this efficiency, are the two purposes. So so that go back to the first basic concept of relation or table. The concept of relation is when we put data in our database, we do not want to waste any space on our table. So if you see a table, they have empty cell. That means that particular empty cell, you record nothing. When you record nothing, that's a waste of space, right? And of course, this type of problem is no longer a problem. Memory becomes so cheap. You waste 100 cells is still just piece of not even a cake, piece of sand. All right, so it costs nothing. But in the past, it cost a lot of money. So you want to make sure every cell in your table are occupied by data. That translates into another concept. Say, no two rows that you are recording data you cannot duplicate. So you cannot have duplicated data, because any duplication of your data is waste of memory space. So the first form, or so-called the first normal form, is we want to make sure that when we put data in the table, every cell of the table is used, and there's no duplication to it. Right? So that's simple understanding about relation. So once you have that idea, whatever the explained on the slide will make more sense. So let's continue to see some example of a relation. So this is a good example of relation. If you look at the first name, Jerry, Mary, Liz, Tom, Eleanor, Richard. Well, it looks like we have some duplication. There's two Tom, but if you look at the last name of the Tom, one is Tom Caruthers, the other is Tom Jackson. So every row on this particular column belongs to some information from different person. So there's no duplication of data, which is good. If you have like two Tom Jackson, then there's something wrong, because you're recording two record of Tom Jackson. Which one is correct? Which one is not incorrect? So those become an issue. But this table is good because there's no duplication. There is sort of every cell of the table is occupied. So that's good. This one is not, and this is called the multi-entry data problem, or the other condition of relation is every cell contain only one data. We don't want to have 2 or 3 or 4 data point, and this one has more than 3 points on the phone number, and this become a problem. Right? So why this become a problem? This become a problem when we ask the following question: says, what is the phone number of Tom Caruthers? Tom Caruthers. What's Tom Caruthers' phone number? And computer will not know how to answer that, because when you ask one phone number but they have 3 answers, so computer will be confused. So this is one of the problem. Of course, this is also a limitation about all the algorithm and data management tool we have in the past, but this become a problem. So every cell can only have one single value. That reduce the problem. And even today, we have a lot of this data or application. You might encounter the problem in the future. I believe this problem exists, is that you call to a say for example Amazon, and because Amazon charge you $100, and you call them and tell them that, oh, I already quit my Amazon account. Why you're still charging me money? And then Amazon asks you, oh yeah, you have to verify who you are. And they say, okay, can you tell me your phone number? And you start to tell them your phone number. And every one of us now have so many phone number. And after you exhaust all your phone number, they say, well, this is not our phone number, your phone number on record. And you're panicked because this is your account, now you can access it. Why is that happening? Because the Amazon, they keep a primary telephone number, try to track every account. And so if you do not change that number, or if you change that number, you have to make sure that is a number we use to search for your record in that account. That concept is kind of similar to your primary key or index we're going to be talking about in this class. But it's likely it happened to me is I use my old phone number all the way back in like 10-15 years ago when I first applied the account. But we switch cell phone, we move around, and I lost that number. And they asked me my old phone number. I forgot my old phone number. So it created a problem in that. So this is a database problem at the heart of the technology. So if you have duplicate number or duplicate information in one cell, that destroy the first normal form or relation definition. This one obviously is not a relation, because now you see there are rows that has no number, no information in the cell. So this type of thing create a problem. There's a second area is that they have data that is not consistent with the column information. You have this fax for home, those are not email supposed to be, right? So an empty cell, wrong information in the cell, those are the problems. So this is not a relation. Officially speaking, this is a table, but not a relation. It can be a table, can be anything, but when you convert a table into a relation, that's where the use every cell, no duplication, write data in the data column become taking effect in the relational database. And this one is in the modern time, we consider that relation. This is this particular slide put in there to tell you the evolution of the database. And very likely, and you will encounter this problem when you are trying to build a database yourself. You always find that people like to leave a space called a comment area, or some remark, or somewhere that they can write a notes into one of the account. And you can probably see this everywhere in webmail, in Outlook, in any spreadsheet-based database. So this is something might happen. So after a lot of people doing this in database, And these type of comments, some of them will just happen to have what? No information on one record, but with a lot of information in one record. And so over time, this become more tolerable in terms of the database design or in terms of the definition of relation. We assume that if you have no data in there, we assign there is a data. So this data, we call them null, N-U-L-L. Null is considered a value. So when you have a null value, you have a value. So in order to accommodate, create this type of table in relational database, but the recommendation is to not use this type of null value too often during the database design stage. So if you do not look at a common column, this table is still a very good relation using our terminology here. If you continue, we have some terminology again in database world, and we need to be clarified. And this is the terminology where I put in here to introduce to you, especially for those of you who work as an information professional. You gotta be professional, so you have to use the word correctly. On the right hand side of the slide, right, the column, I have three terminology here: row, tuple, and record. Right? Row. I'm sorry, wrong. Not on the right. It's on the top of the table here. The light green color, at least on my screen, look like a light green color. You have table, column, and row. Those are the three elements consist of a table. In the middle part, you have relation, attribute, and tuple. Right? The light blue row that you see on the slide here is the terminology we use officially in relational theory. So if you're using, if you really want to become a relational database professional, well, I should not say that. This is probably used more in academic now. So if you use the term tuple to represent row, attribute to represent column, and relation to represent a table, this is the way we say in relational theory. Right? So relation, attribute, table, that's the official name. But most likely in practice, you will see the one on top: table, column, and row. The one at the bottom is a legacy of a traditional database. I will advise not to use it. Right? So even in today's NoSQL environment, do not use the terminology called file, field, record. That is the terminology, although that is a set of terminology we use for hierarchical database. Right? Hierarchical database. And again, we are not using that today. But on the other hand, we do have some of the modern data standard going backward to use hierarchical structure. This including the XML and the JSON database structure. So that's a lot of time this become very confusing, and there will be communication problem in the work environment when people say something they are actually meant the other thing. Say for example, among all these words that you see here on the slide, the term file is most confusing, because usually we think a file is a physical, as a matter of speaking in the computer world, save on your computer. But in traditional database, it actually represent some sort of a data structure. Right? So that's something. So the first segment of the recording will stop here, and here we just introduced two important relational database concept. One is something what we call relation. So think about what is the definition of relation. Going through the lecture we have, and it's actually equivalent to table most of the time, but it is a more rigorous table. We try to make sure that we do not have data duplication, do not have waste of space, do not have issue that can generate incorrect data. The second thing is there are confusing set of database terminology to describe table, which is the basic element of a database, and you need to be familiar yourself. But as a practitioner myself, the recommendation to use is try to use the top upper part as much as you can. Table, column, row. avoid using the blue or green. But you have to know that when people say relation, it is actually talking about the database table we are talking about. If you are talking about a table in Excel spreadsheet, most likely they are not relation, right? They're most likely you can only call them table. Right, so that's it. Emphasize two set of terminology we want to learn in this class. And I'll stop the recording and continue into the next recording.